So, hi everyone, and thanks very much. I'm filling in for Raul Alvarez, who had to cancel his talk, so I'm not going to be talking about open source ransomware. Instead, about a little side project of mine, hacking bike sharing services. So, a couple of words about myself. I'm working in InfoSec since like 2008. I've worked as a penetration tester in the past, and from that time on, I started looking differently at software. It's very interesting to a new way to play with software. And in my part-time, I also have a lot of pets, like 40,000 bees. And I'm also a lot of my time on Twitter. So the motivation to look at those bike sharing services is, on one hand, when I was working as a penetration tester, I had a look at a lot of different technologies, but often the projects were focused on web applications or on maybe some native applications, but I never had the chance to look at mobile applications closer. So this is something I had on my bucket list I wanted to do, so I needed some example of something to have a look at. And 2 years ago, when you looked at the streets, there were more and more yellow bikes or green bikes or black bikes that would come up, and it was the beginning of those companies who would, mostly startups, who would start deploy their bikes. So I got curious and downloaded an app and wanted to analyze it. But in the end, the mobile part, the analysis of the mobile application was only the smallest part, actually, of the whole thing, because it involved not only the mobile part, which is not so extensive, but also the server side parts, which are mostly REST applications, then the hardware on the bikes, like this one, which is a bike lock, and and also psychology of when you disclose vulnerabilities to the parties and the whole process of communicating with them. So how does it look like in Zurich, in my hometown? We have, I think now there's also more services deployed than these four. It all started with Smide in fall of 2016. It's a Swiss company. Then in summer of 2017, Obike came along. And then we had an American company called Limebike, which I haven't looked at, so it's the only one I will not be talking about in this talk. And then in May 2018, Publibike, which is another Swiss company, started also deploying their bikes. There's a little difference with Publibike, because their model is you can't just pick a bike on the street and ride it and put it anywhere you want. You need to bring it back to the station to end your ride. But apart from that, there are a lot of similarities to the other services. So, how do these services work from the user point of view? You need a smartphone. Without a smartphone, it won't work. Maybe for Publibike, there you can go with the Swiss Pass, which is actually the public transportation card. So you can just badge in with your Swiss Pass. But apart from Publibike, I think every other service require you to use your smartphone to use them. So you need to install the corresponding mobile app on your smartphone. You sign up. You need to load some credits with your credit cards. For some services, you also need to cash deposit. Like for Obike, I needed to pay in 130 francs. That was at the beginning, which we can think is roughly the price a bike would cost if you wouldn't bring it back. And just to let you know, I never got those 130 francs back from O-Bike. So if you're listening, I'm still waiting. So once you loaded your account with money, you can again go on and the main screen on those apps are mainly a map, an interactive map, like a Google Maps view, where you can locate the bikes where they are in your neighborhood. And once you walked to the bike, you can start the lease, you can start riding it, and during the ride, you will be the costs will be running. And when you're done with the ride, you just log out and close the bike, and then the costs stop. So this is basically how to use such a bike sharing app. So if we look at what could go wrong with those bike apps, first of all, there are operational issues. If you take the perspective from the operator of a bike sharing app, you want to generate revenue. So you want to, in the first place, avoid that people can bypass your payment. Otherwise, well, that they can get rides for free. On the other hand, you also are concerned with availability, because if no one, even if the people are willing to pay, if the people are not technically not able to use your service, then you're also not going to fulfill your financial requirements. Then something else is you have also data protection issues. You don't wish that somebody is able to see all the personal data of your customers, so you need to make sure to protect that as well. Then there's also safety and liability issues, because people are going to use your bikes. You need to make sure that they are in a good state, so that people won't crash and maybe get injured or killed. So it's, I don't know, I haven't systematically read all the terms and conditions. I guess the people would try to, the operators would try to pull the responsibility on the user side and tell you need to make sure that the brakes are working and everything. But we'll see in one case that the users can't be held responsible for every single thing. Then in the end, you also have a business impact due to the financial loss that we talked about just before, but also you could have some reputational damage, like for instance, if you don't pay back the deposit of your customers. Okay, so let's have a look at the first bike sharing service. It's called Smide. It's based in Zurich. So as I said, they started in fall 2016. Initially, they were backed by an insurance company. And I read an interesting article about why this insurance company wanted to start that service. They were interested in the future of mobility and when like using cars, car sharing schemes, and how it would look like for the insurance. Because obviously, if you want to rent a car like that doesn't belong to you, then you need to think about how you're going to invent the new insurance schemes of the future. So it was kind of like a test bed to see how to analyze the behavior of people when they have such digital mobility with such services. In the meantime, the company Smide is independent, and I think they're doing quite well. If you look at the hardware, so that's this bike, it's produced by another Swiss company called Stromer, and they're pretty high quality bikes with a high price. So in the upper segment, they're like 6,500 francs per unit. And it's comparable to a little motorcycle because there are very powerful motors in them. They have about 400 bikes. I guess this number is pretty much higher now, because this was, I think, 2 years ago that I looked at all the bikes, via the API. And how do they manage the fleet? They have actually, the bikes are totally autonomous. They have, mobile connectivity, and they have a GPS inside, so the bike itself can communicate its location. This will also help for theft protection. There's one thing the operator needs to think of or needs to implement is that these bikes have a battery. It gets, when you use it, it gets low. So you need a team of people who will do maintenance of those bikes. So you need to go to the bikes, you locate it via smartphone, you go to the bikes, you exchange batteries, you need to look for enough air pressure in the tires and everything else that could go mechanically wrong. So this is kind of like the price you need to pay for to maintain this fleet of high quality bikes. So how's the overall architecture for the operation of such a fleet? So as I already said, the bike are autonomous. They can communicate by themselves. They can have they can figure out where they are, and they will communicate their location to the backend via mobile network. On the other hand, the users also have a connection to the mobile network and to the Smide backend, and so they can meet and do the bookings and so on. So let me give you a first example of how the backend communication looks like. So this is a product of the analysis done on the mobile application. As you see, it's a totally standard REST API. So we have a GET request where you can, in this case, download the locations of the bikes. And what we get as a result is an array of records, each with a bike ID, in this case 46. Then you have in the name, it's just the license plates. So ZH is for Zurich. You have a battery level. You have a battery range, I guess in kilometers. You have the size of the bikes because they have two sizes, so I guess it's in inches. And you have a geolocalized address, as well as the latitude and longitude. Okay, so what if somebody was like, okay, it's a nice bike, I want to take it away and try to break it open. The bike have like kind of a geofence. They first of all, you're not allowed to leave the bike or take the bike outside of the geofence. And on the other hand, if the bike is locked and you move it only from a couple of meters, and the bike has a logic that will say, okay, now I'm being taken away, and it will trigger an alert, an alarm. What it does, you don't have any lock you need to close yourself on those bikes. It has an electronic lock on the rear wheel. So actually, if you want to ride the bike, and you didn't unlock it, the rear wheel would just be blocked. This will be important for later on. So let us look at the booking process. At first, you need to locate a vacant bike, which is, of course, locked. Then, in the first step, what you're going to do is you're going to unlock you're going to start a booking, but the bike is still locked, and then you're going to unlock the bike. You can only lock or unlock the bike if you have an active booking. So let us look. At first, we need to talk about the authentication scheme. So the first request is on the login endpoint. You just provide your username, which is an email address, and your password. And what you will get in return is your user ID, a technical user ID, with a JWT structure, which is actually a JSON Web Token. And since the JSON Web Token is a bit long, I made an own slide for it. A JSON Web Token is a structure which contains three parts, the red, the green, and the orange part, which are all base64 encoded. So if you decode that, you're going to get a header in red, where you get the hashing algorithm, and actually it's a HMAC algorithm. And the green part is the body, where you have all of the user-related data for the authentication. So you have the UID, which is a technical user ID. You have some timestamps and how long the ticket is valid. And the orange part is a signature of a digital signature of this ticket. And if you want, it's like OAuth uses it, or also similar to SAML, where you actually, for the authentication, you go to one party, to an identity provider, and it will guarantee that the bearer of this token is really the one who should be accessing. So it's just a session ticket if you want to make it really simple. Okay, so let's see how we go from a free bike to a booked bike. You need to first have an authenticated session, and you post on the booking REST endpoint. Yeah, so in the header, you provide the JWT token, and what you say is you want to start booking the bike with ID 133, and this is my user ID. The server will respond with a new REST structure and will tell you, okay, the booking ID is 12345, and you're currently not using the bike. So the usage key means, are you using the bike or not? If it's false, the bike is locked, and if it's true, the bike is unlocked. You also have a PIN that we'll see afterwards, and a timestamp. Okay, so now we're in the booked state, but the bike and the bike is unlocked, and now we want to see what happens when we lock the bike. So we refer to the booking number or ID we use, this 12345, and we're going to post or make a put request on the booking endpoint and say that we are done using the bike. And why do we have this differentiation between a booking and the locked state? Is because I guess the use case is you picked up a bike somewhere. Maybe you needed to walk 1 kilometer to get a bike. You got the bike, and now you're riding in somewhere, maybe to do your groceries, and you want to leave the bike outside of the grocery store. But you want to keep the booking running because you don't want to have somebody else take the bike away. So the state is still booked, but the bike is locked. So this is what we're doing now. We're locking the bike. When you lock the bike, the endpoint will return a PIN, this 49637, which you can use actually on the bike to unlock if you want, but you could also do it via smartphone. Okay, now the problem is, there's a vulnerability in this scheme where actually the booking numbers are sequential. So the next customer who would book a bike would get the number 12346, and you could have a look at all the bookings in the past by just decreasing this number. So the problem is there's a problem of authorization, because if I do the same request, but now you see in the authorization header, I'm using a JWT of some other user, which I don't know, and I lock the bike as well, I get a positive response. This means I just locked somebody else's bike while he was riding, and I don't know him. It's just, so that's kind of not neat, because anywhere in those 400 bikes, in the fleet. Some people are riding, and I go over all booking IDs and I just lock all the bikes. So what happens, I tested it, is the bike won't just brake while you're driving it, fortunately. But what happens is, as soon as you stand with the bike, as you're not riding in anymore, then the rear wheel blocks and you can't go any further anymore. So imagine you're at a red light, at a crossing, you just stop the bike and then you want to go further, but no, you can't, because the bike the rear wheel is blocked. Okay, so I figured that out on a Friday night. Well, actually, it was already Saturday morning at 1:30 in the morning when I sent the report. Well, I told you it's a side project, so I wasn't doing that at business hours. On Sunday, no, that was still, I think it was from Saturday to Sunday. So on Sunday, I got a first answer from the customer support, who told me, okay, I'll forward this to the people concerned. And a couple of days later, I got a reply from the product owner that told us that they had already fixed it on Monday, and all was good. So I was really happy that they took it seriously, and I got 100 minutes for free to ride on the bike. Okay, now let's turn to O-Bike, which are those yellow bikes. I don't know in which other cities in Switzerland they were deployed, but like for 1 year in Zurich, you could go anywhere and you would see one of these bikes. So in contrast to the Smide bikes, they are very cheap bikes. They have no motor. There are no e-bikes, so it's like, yeah, you have to do sports. But the problem is they are also single speed, and Zurich is not only flat. I could imagine in Lausanne it's pretty unfeasible to use those bikes because it's like steep everywhere. Those bikes were designed to be maintenance free. They were like designed to be dropped everywhere in the street, and then they don't care about them anymore. This is why they have solid rubber tires. And they have a really cheap fare. As in comparison, it's 5 times less than the Smide. And they were deployed in several countries worldwide, in several cities, and European cities like Munich, in Amsterdam, I think also in Paris, in Melbourne, Australia. Yeah, I can't remember. It was really a big endeavor. So, how do they work? Their architecture is far more simple than the Smide bikes. Why is that? Because the bike is not totally autonomous. The bike's logic is actually in this lock right here. The rest of the bike is like a convenient, normal bike, conventional bike. So what you have here is actually a lock which has a solar panel, so you don't have to change batteries. And I guess the battery is the most important or the most valuable part in the whole lock. Because it's like a big battery, and you can use it for other projects as well. What it has, it has a Bluetooth connectivity, so you can communicate. So the smartphone can communicate with the lock, but the whole communication to the O-Bike backends is run through the smartphone application. So the lock itself will never be able to directly communicate with the backend. So if nobody is using the bike, you won't know where this bike is. So let's also first have a little peek at how the REST API looks like. If you want to have a list of all the bikes in your vicinity, you just have this very simple REST call where you give as parameters your current location. This is the location the smartphone has. So actually, all location or positions you are going to communicate to the backend are always the one of your smartphone, never the one of the lock itself. It just assumes that you're in the vicinity of the lock, and hence you can use the the position of the iPhone. And how does it look like in the response? You get also an array of JSON objects with a bike ID. The bike IDs are always the international telephone code. So like it's 041 for Switzerland and then some sequential numbering. And then you have the stored position, because you can actually, the phone can put a position into the lock, and it will store it. It will be persistent, but it will also communicate it to the backend. So this is why the backend will say, okay, this bike should be at that place. What's interesting here is that you have an IMEI field that's, in my understanding, or the first thing I thought, it's an international mobile equipment identifier, but that's not the format of an IMEI. And you also have a country ID, so 167 is for Switzerland. So from that, you can draw a map and map all locations of the bike. So I don't know when I did this, probably sometime in September 2017. The fun thing about it is actually, since the bike itself can't send its location, the smartphone is actually doing it. So this is a REST call where you put the actual coordinates of the bike ID, 041, blah, blah, blah. Well, you can actually spoof the location yourself. So, instead of having that, you can actually take all the bikes and put them in the Lake of Zurich. So, but I never did it. Would have been fun, but. And we also clearly see some, if you want to do attribution, the origin of these logs. These are Chinese logs, which you could buy online. And this is also one source I used to first identify, because I bought these logs after Obike went bankrupt. From a moving company that made a deal to collect all the bikes, and I contacted them. I told them I would like to buy some of the logs, and this was only like last summer that I did this. And before, I only had images from the FCC, because they registered their hardware in the US, and all this information, technical information for the FCC regulation is available online. So you can see how the lock looks from inside. You can see, you can learn about the mechanism, how it is used, and what kind of chip there is. So there's a guy in Australia who took apart one of the locks, and he made a video out of it. So there's a link if you want to look at it. And so from there on, I knew what kind of chip is inside. So it's Texas Instruments ChipCon 2541. So you can get the spec, and out of the spec you can see it's a SoC, a system on a chip, which is used for Bluetooth low energy communication. And it has a coprocessor that you can use for cryptographic operations like AES. But what stands out here is that there are only symmetric operations. I highlighted the CBC MAC because I thought, okay, how do they want to implement like a signature scheme? Because when you open the lock, you probably want to say, okay, open and now sign this operation. And so this was just an assumption that they would use CBC MAC, which is kind of like a symmetric digital signature scheme. Okay, so I started without having a lock at hand. I still used my smartphone and started sniffing the Bluetooth communication, and came up with this, that Bluetooth command structure looks actually like this. You have a small preamble, you have a length field, a command field, and then a payload and some check. You have one bit that tells you in which direction the information flows, and the check byte is actually kind of like a CRC checksum, a very simple one. So usually what you do is you have a first hello message sent from the smartphone to the lock, and you are first going to store the coordinates on the lock. So these two fields are the actual latitude and longitude the smartphone has, and will store them on the lock. And the lock will respond with a 32-bit challenge that you will use afterwards to send via REST API to the backend. The backend will answer with a key index. This is the byte, this 8B byte, and then, which looks like an AES payload or like one block, but which was truncated to 96 bits. In the REST payload, you can see there are 128 bits, but only 3/4 of it will be sent to the lock. And why, I don't know. Because what you get in response is like an acknowledgement package, which is also kind of like signed with this 128-bit AES something. And there you have enough space for the 128 bits, so I have no idea why they truncated it. But, okay. So the assumption is it's a symmetric cryptographic scheme, and that implies that the keys are actually all stored on this chip. So the goal now was, well, let's find out if I can extract it. So I'm not a hardware guy. It was all new for me. But I saw on those FCC pictures, something that looked like debug pants, and which made me buy something like that, a CC debugger, which is designed to debug this line of chips. But unfortunately, to use this, you need to wire it in the right way, and then the green light lights up. But when I did it, it never went green. So I was kind of like demotivated and left it on the side for some time. In the meantime, a group of students from the National University of Singapore came up, also analyzed the Publibike scheme protocol, and came up with a super cool vulnerability that I didn't see because it was like too big. So how does it look like from high level? So you have the Publibike on the left side, the mobile app in the middle, which is the man in the middle, and you have the Publibike backend. So what you do is the Publibike lock generates the 32-bit challenge. It gets sent back to the backend. The backend generates a response, sends it back to the lock, and at that moment you have the acknowledgement. Well, at that moment the lock goes up, and it generates an acknowledgement which you should send to the backend, and then the backend starts billing. So do you see the problem? Okay, I see nodding. Yeah, there's the problem. You just omit the last message and you're good. So I have a little demo for this. And okay, I just need to make sure that I have internet. That's good. So I also need to... Good. So I'm going to take this one. Everything that's red is information going to the lock, and if anything green is information coming from the lock. So let's test it. It doesn't work. Okay. Of course. I was so naive to think it would work. Okay, now it should work. So what's interesting is... Oh no, it was the other lock that went off. Sorry. Could do it again. So what's interesting here is that I'm actually... Yeah, now we have it. I'm actually communicating with the Publibike backend, and they're still online, although they went bankrupt. So we should, this is a response actually, and we can see on this line here that we're sending up to the last byte only 96-bit of those 128. Okay, so let's go back to the... But once you do that, you get another problem, because you get this response. Obike's backend thinks, oh, I didn't get an acknowledgement. This bike must be broken. So you can do this once with one bike. Afterward, you can't use the bike anymore for 24 hours. So that's a denial of service. They changed this behavior afterwards, which opened a new vulnerability that we will see later on. I'm kind of running out of time, so I'm going to skip this part. They changed the API sometime in September 2017. All the requests looks like that. They started encrypting those requests. If you ask why, I think it has to do with this news report that somebody found a way to steal all the data of all users of Obike, and then, technical measure, encrypt all the things. Too bad that the encryption key was actually inside the mobile phone. So if you're interested in the encryption scheme, you can have a look at this wonderful initialization vector in orange, and you could see that's not very good practice, but okay. So using those keys, you could actually transform this encrypted request into this again. Then, in the meantime, another security researcher looked at the logs in parallel like me, and he did a talk at last year's DEF CON. He actually managed to wire up the thing like you should be and get the green light running. But unfortunately, when you flash the firmware on it, you have the option to tell that you don't want somebody to download it again. So you seal off the chip, and this is what happened. The chip is locked. You can't download it again. So I thought, let's try something new. How about fuzzing? So I'm not an electronics guy. It looks awful, I know, but it was fun to do. What I'm doing here is actually I needed a switch, an automatic switch to turn the board on and off. This is why I'm using this relay, which might be a bit oversized for this voltage, but it works. And on the other hand, as an feedback, I wanted to know whenever the board would activate the little motor that would open the latch. And the idea was then to fuzz the payloads and see if sometime I get current on those motor lines. I didn't manage to do it, or I didn't do it long enough, but I still had 3 surprising discoveries. The one is the challenge that you're sending is not random at all. Actually, it's the number of milliseconds since the board was powered on. So I discovered it because I was always taking the power off and then on again. And I saw, well, it's always you have a lot of zeros in this challenge. Second, the response that you get when sending a challenge can be replayed. And that's pretty cool. And the third thing, the third element is I discovered a new command type that wasn't in use in the smartphone application. Is when you send this command to the lock, it will reboot. I don't know if it's a crash or if it's intentional, but what happens is it works. So I can actually trigger a reboot from a remote. So it looks like this. This is what we had, the scheme. And now, what happens is you want to get rid of the backend. And I'm going to first reset the chip so that I know that I'm at the beginning of the counter. Then I'm going to generate a challenge. And in the meantime, I downloaded all possible responses for 20,000 challenges. So this gives me a window of about 20 seconds for which any challenge I can look it up. And I just go and look up the response for the corresponding challenge in this lookup table, and I give it back to it. And this led to a vulnerability which I published. So, time for the second demo. And here, the only difference, so I need to close it again. The only difference is you're going to see red and green, but you're not going to have any communication with the backend. So it's a total offline hack if you want. Okay, that's not what I wanted. Thanks. So can I have my slides back? Okay. And the story is not over yet. There's a guy who created a Twitter account called OpenBike, who started tweeting during the C3 Congress last December and said that he developed an Android application that lets you open the locks. So he could extract the keys, but unfortunately he hasn't talked about it yet, and I tried to get in contact and I didn't hear anything about it. Okay, so I have 5 minutes left. I'm going to talk at last about Publibike, which is deployed all over Switzerland. It has more than 8,000 bikes, and they have conventional bikes as well as e-bikes. Their operation is like this. You need to take the bikes from the station and bring them back to the station, and the whole logic or communication goes through the station. The station has mobile connectivity as well as Bluetooth to talk to the locks. The locks are in the function pretty similar to the O-bike locks. And then everything else is handled over via smartphone app, also via mobile connection. They suffered a vulnerability of mechanical nature, actually. People find out that you could just hit on the lock and they would open up. So this is pretty bad. Media coverage didn't get it really right because they said people were able to open it with a handy. So I guess they took their smartphones and just hammered on it. But yeah. I also found conceptual weakness in their service, which I cannot disclose yet, but they were aware of it, fortunately, and they're in the meaning of in the process of fixing it. It was, or it is, a pretty obvious one. As soon as you have more details about the architecture, it's a really, really obvious one, but it's in the process of being fixed. Maybe they also should do a public intrusion test because they're also a subsidiary of the Swiss Post. Okay, so conclusions. When you're starting with such a service, don't forget to think about security and risk management. Think about what could go wrong. If you have some more budget, then do a security audit and get rid of the low-hanging fruits, because otherwise other script kiddies will find them out and it's not good for your reputation. And don't be naive. Flaws will be found with time, and the keys, cryptographic keys, will be leaked. I mean, you have one Achilles heel in the O-bike. It's the key that's inside this chip, and it has not yet been leaked, but already been discovered. So make the devices fixable. Make it design some interface to be able to update the keys if you rely on them. Okay. This is all. Thanks a lot for your attention, and
thank you. Is there any question?
Thanks for the talk. Yeah, really, really cool, interesting topic. I love it. Obviously, I guess, there are similar services with e-scooters as well now. Is that something you're looking to look at some point? Would you say it's similar technologies being applied there?
It's certainly interesting. At the moment, I really have no time left to look into it, but it's definitely worth looking at. I hope they are more mature than the first generations we had, in the last 2 years. And I have no idea why O-Bike went bankrupt, but I could imagine if they didn't go bankrupt for financial reasons, maybe for technical reasons.
Any other question? Well then, thank you for your time, and your presentation was nice.
Thanks a lot.